So here is a little summary table of the similarities and differences between abstract classes and interfaces. This tends to be sort of a classic Java interview question. So if you happen to be going out on an interview, this is a good topic to brush up on. So here lists kind of, again, just some of the different characteristics. So both abstract classes and interfaces can be used as the declared type, and neither can be used as the actual type. So you cannot instantiate an abstract class and you cannot instantiate an interface. So they're similar in that way. They can both be used as a declared type and neither can be used to instantiate. Abstract classes can contain constructors, but interfaces cannot. So that's a big difference. An abstract class is a class just like any other class, so it's allowed to have a constructor. An interface cannot. Both of them can contain abstract methods. Abstract classes can also contain implemented methods, and only as of the most recent change to Java, so can interfaces, but these are usually typical, small, what's called default methods. You're not going to have a full long method written typically in an interface. So technically you can have an implemented method, but it's a little bit different, the kind of implemented methods you'll see in an abstract class versus an interface. But technically you can now have an implemented method in an interface. Both abstract classes and interfaces can contain public static final constants, so that's a similarity. But any other kinds of variables, not allowed in an interface. Whereas an abstract class, because it's a class just like any other class, it can have private instance data variables, it can have protected variables, it can have any other normal kind of variable that you can put in any class, because it's just a class. Interfaces can only have public static final constants. And then the other really big difference is that a class can only inherit from one class. So every class can only have one parent, but a class can implement as many interfaces as they want. Okay, so some important commonalities between abstract classes and interfaces, mainly this up here, that you can use them as the declared type, but you can't instantiate. But then a couple of important differences too. And of course, what isn't on this slide is sort of the theoretical difference about when you should use an abstract class, and that's when it falls into your inheritance tree about what the object is, versus when you should use an interface, and that's more about the functionality. So there is one very commonly used interface that Java gives us, and that is the comparable interface. So comparable is an interface that specifies that two objects can be compared to each other. If you can compare two objects, you can then create an ordering of those objects. So you can say, hey, object 1 is smaller than object 2. So if I know that information, I can put them in order. If I have 10 objects of the same type, and I can compare them in pairs of 2s, so I can compare any one object to any other object, then I can again order those objects from smallest to greatest, or greatest to smallest, or however I want to order them. So the comparable interface is the way that you specify how two items get compared. And you do that with a single method that's in this interface, and it's called the PartTwo method. Now, many Java classes implement the comparable interface and thus implement the PartTwo method. For example, the string class does. So some of you might have invoked PartTwo on two strings to find out which string came before another string. That you can do that because string implements the comparable interface. Now, any of our classes, we can also implement comparable. And we can decide how objects should be compared to each other. So we can say, well, if you're going to order a bunch of employees, let's order them by name. Or let's order them by ID. Or let's order them by hire date, or whatever we want. So we get to decide how things get ordered. This is similar to how we got to decide what makes two objects, quote, the same. Right? We can say if two employees have the same ID, they're logically equivalent. Or we can say only if two employees have the same name, ID, and phone number are they logically equivalent. We get to decide what makes them equal. That's the same thing with PartTwo. We get to decide how our objects should be ordered. And once we make that decision, we put that implementation inside the PartTwo method. So again, there's one method in this interface, and it's called public int PartTwo. And just like the equals method, it takes in one parameter of type object. So this is the method header. Now, there is one change you can make to the comparable interface to use something called generics, which we're not going to go into in this particular lecture, but I'm going to just show you how to use it, and I'm going to suggest that you should use it because it's an improvement to the compare-to method. But don't worry if you don't really understand what's going on here, okay? Generics is a separate topic, and I don't want to talk about it here. This is one of those use now, understand later things, okay? So for now, you can just use the generics, and we'll worry about understanding it later. So the difference is that instead of having your class just implement comparable, if you have a class called my class, you would say that it implements comparable, and then in the angle brackets, you'd again put the name of your class. Essentially what this is saying is that, I'm actually not creating a way to compare my object to just any other object out there. Like if I'm working in my employee class, I'm not actually writing a method to say to define how to compare an employee to a string or to an audio item. Like that doesn't make sense. I'm only defining how to compare an employee to another employee. That's the only thing that makes sense. And this use of generics here allows you to specify that. So it allows you to say, I'm really only going to tell you how to compare two employee objects, as opposed to comparing an employee to any other object that's out there. Now the difference if you use this generic version, which again I'm going to encourage you to do, is that instead of taking in a parameter of type object, you get to take in a parameter of your own class. And what that means is that inside the method you get to avoid the whole rigmarole of checking whether the object is the right type and casting it, and then taking some action if it's not the right type. So that's where the big improvement comes in, is you get to avoid all of that. Now, do not be confused about equals. You cannot do this with the equals method. The equals method has to take in an object. End of story. No ifs, ands, or buts about it. Okay? For the equals method, overriding that method, the parameter type always has to be object. Okay? I rarely say always or never in programming because there are usually exceptions, but this is one of the times when I will say for the equals method, the parameter type always must be object. Okay, but for compare to, you have this option of using this generic structure. And again, I'm going to encourage you to do so because it is a bit of an improvement. So the compare to method, you'll notice, returns an integer. So it's not a Boolean. Equals returns a Boolean, right? Either two things are equal or they're not. But compare to returns an integer, and that integer allows you to know whether one object is greater than, less than, or equal to the other object. So what the compare to method returns is if the invoking object, object1, so that would be the method on which you invoke the the object on which you invoke the compare to method, compare to will return a negative number if that object is less than the object you send in as a parameter. The compare to method will return a positive number if the invoking object is greater than the object you send in as a parameter, and it will return a 0 if they're the same. Now, you don't know what this number is, so one mistake I see quite commonly is that people assume it's a -1 or a 1. That isn't the case. You only know that it's going to be negative, positive, or 0. So if you're using results that you get back from a compare to method, you never want to check whether the result is exactly equal to some number. You just want to check if it's less than 0, greater than 0, or otherwise if it's 0. So here's a little example of us invoking the compare to method. So we could say, if object1 dot compare to, and then send in object2 as a parameter, and if this result was less than 0, what that means is that object1 is, quote, smaller than. However, we're defining smaller than to be, right? Maybe object1 has a name that comes earlier in alphabetic order. Maybe they have an ID that is earlier in alphabetic order. Maybe they have a higher date that was sooner than another higher date. So it's whatever we decide, quote, less than means, but it means that object1 is less than object2. If the result of that compare to is greater than 0, it means that object1 is greater than object2. However that comparison means, whether we're comparing names or IDs or start dates or whatever. And if it's not less than or it's not greater than, that means it's equal to 0, and that means that these two objects are the same. So again, it's up to you to decide what makes one object greater than or less than another object. So for example, with strings, it's alphabetic ordering, but case is considered, right? So if we were to take two strings and compare them to each other, we'd look at which one comes first in alphabetical order. That's how the string version of compare to is written. When we write our own compare to, we get to decide what makes one object greater than, less than, or equal to another object. Now, in theory, if your compare_to method returns 0, that should mean also that your equals method is true. So in a perfect world, those two things should line up. Sometimes your compare_to method will be pretty simple. You'll just basically compare two instance data variables and use the comparison of those instance data variables to return your value. So if you just wanted to compare two objects based on their name, you can use the compare_to that exists in the string class to implement into your compare_to, and that's pretty common to do. But you can also get very complex, so it's kind of, again, up to you what you want to put in that implementation. Now, why do we do this? Well, if we have our classes implement the comparable interface, we get a lot of nice things. Mainly, if we can compare two objects, that means we can sort objects. That's really the only requirement for being able to sort things, is being able to take two objects and say which is smaller, which is bigger. If you can do that with objects, then you can sort them in a whole variety of sorting algorithms, any sorting algorithm out there. The requirement for any of those sorting algorithms is that you're able to compare two things, whether one is smaller or bigger than the other. So if we implement comparable, not only could we write our own sorting algorithm, but we can use these really nice sorting algorithms that Java gives us in the standard class library, such as the method collections.sort, which allows you to sort any array list by just passing it as a parameter, or arrays.sort, which allows you to sort any array just by passing it as a parameter. So that is pretty cool. We can sort any array list, we can sort any array with a single method call, but this only works if the class that fills up this array list or the class that fills up this array implements comparable. So implementing comparable allows us to do really nice things like sorting lists of objects, sorting arrays of objects. But the only way we can do that sorting is if Java has a way to compare two things. And the method it uses to compare two things is comparable. Now, it's important to note that implementing that compare_to method doesn't actually sort anything. It doesn't actually order anything. It just defines how two objects will be compared. But being able to do that, being able to compare two objects, that is the requirement, that's the functionality we need to be able to sort things, okay? So it's another common misunderstanding I see, that people think, I have this compare_to method, but my array still isn't sorted. Well, the compare_to method doesn't actually do any sorting. It just allows you to pass in an object and say, hey, is this less than the current object, greater than the current object, or is it the same as the current object? That's all it does. All right, so let's take a look at what this actually looks like with our own classes.